Hey guys, how are you? So it's Nevin here. Just wanted to talk to you about the example that we spoke about last week, and just to say that I mentioned that there's asynchronous and synchronous learning. So today's example is an example of asynchronous, where this is pre-recorded. So please let me know if this suits you. So we had four examples last week, and I asked you to do a little exercise on it. And the first one was A, and it was 10 meters by 10. Second B, 5 by 20, and so on and so forth. And the task was to calculate the floor area and the wall area in each instance. And in, I suppose, the first example, it's the most straightforward. You would have had 10 by 10 would have been the floor, and then to get the wall, it's the external walls. You had to add 10 plus 10 plus 10 plus 10, and then assume 2.5 meters in each case. So you would have had 40 by 2.5 would have been 100. So you had 100 square meters for your area of your floor and 100 square meters for the area of your wall, which would have been a 1-to-1 ratio. And then you would have had to do the same for each of the next B, C, and D. And the question is, out of this, the question is which is the most efficient shape. So if you can imagine that every area of wall costs you an extra, let's say every square meter, imagine that that costs you an extra 500 euros, for example. Is the client gaining anything extra? Normally when clients give you a brief, they're thinking in terms of floor area. So if you can give them the same floor area but reducing the overall cost, because you're reducing foundation cost, you're reducing external wall cost, you're reducing insulation cost, plastering cost, heating cost. If you can do that, then you'll always have happy clients. So if we look at the next slide down, we can see the calculations here, and here's an in-depth analysis of those calculations. So here A, you had 40 meters girth. So girth is just the perimeter wall, the total length of the external wall. And it was 2.5 meters high, which means that the external wall area was 100 square meters. Now I should say the 2.5 in this case is just an example. Obviously if you're doing floor to wall ceiling area, you're going to have 2.4, but then you're also going to have the depth of the joists or the build up above the ceiling level, maybe an allowance for the thickness of the floor finishes, etc., etc. So this is just an example. So your ratio there is A 100 to 100 equals 1. And in each of the other three, you have 50 meters girth. So you have 10 meters more, or if that's expressed as a percentage, you have 25% more. You're going 40 meters to 50 meters. And the effect of that is that you've got 25% more wall area, 125. So you have 125 square meters of wall to 100 square meters of floor. So that's basically a poor ratio, poor floor to wall ratio. So that's something that you'll be asked to do as part of your project, is to calculate the floor to wall ratio of the project that you're going to design. So if we were to move on, we spoke about this last week and we talked about what's the most efficient, and the circular plan would definitely produce the most favorable floor to wall ratio mathematically or theoretically. So maybe if you had like a 3D printer or something like that and you were printing this structure, then it would be theoretically the best ratio. But the cost of constructing curved walls, curves are the most expensive. Please avoid, if you can, avoid curves. And that's if your goal is to reduce money and to be efficient. Sometimes that's not your goal. Sometimes the brief is to create something dramatic. So if you're designing the a new convention center or a new opera house, for example, or a stadium, then you might want curves. But just be mindful that they're more expensive than straight walls. We'll talk about elements. So we're going to talk about the national standard of building elements, and between now and next week what I'd like you to do is I'd like you to Google the National Standard of Building Elements. See if you can find a research paper. Particularly good papers I would recommend would be Tony Cunningham's explanation. Tony is a lecturer here in TU Dublin. So if you were to Google or go onto arrow.tud and maybe just search the words Tony Cunningham and National Standard of Building Elements, you'll find some information there. So you can do that as part of your research within the next week. And you'll learn what is a standard list of elements and how do we apply them as surveyors to the buildings that you design as architects, and then feed that information back onto you. So if you look at the elemental basis, the elemental just breaks it down into each individual component and it groups them together. So if you were to look at a rectangle, imagine if this building on the left, if this occupied the same floor area as the building on the right. If you were to do a planning search and search houses that have been built over the past 20 or 30 or 40 or 50 years, you'll find an awful lot like this, where they have multiple projections, wants, recesses, corners, feature bay windows, feature conservatories, different roof structures, hips, valleys, gutters, gullies. And all of those additional elements, additional design shapes and features, if you like, cost money. They have a dramatic effect on cost. The most efficient structure to design and build is a simple square or rectangle in most cases. Because of spans of timber, the rectangle is going to be the most efficient structure. And then if you think about energy costs, you're also going to have a huge saving by having a compact rectangular structure. If you're learning about passive construction, they always go for simple compact rectangular shapes. Again, to keep that floor to wall ratio low, and also to eliminate thermal bridging. Every time you see a little circle there, that's a junction. That's in this case, they're all 90-degree junctions, and each one of those 90-degree junctions has the risk of thermal bridging, has the risk of damp, has the risk of structure failing. Here we've only 4 junctions. There's, well, count them up yourself. There's a lot of different junctions. And then when you get above, so you've moved from the foundations through the walls, you got up to the roof. All of these roofs then have to tie in together, and almost always there'll be some sort of a problem with water ingress where different shaped roofs try to tie in together. You end up with valleys. If you can avoid valleys at all, you should try and avoid valleys. So you're going to definitely end up with valleys there if that's a pitched roof. So we try and avoid that. And you can see a list there of the other elements that it has an impact on it also. Okay, so these are some of the effects. And there's been a trend in the last 10 years from the local authorities to employ architects to produce design guides. I would recommend that you search the design guide in your area and look at some of the suggestions as to how to improve things. There's an excellent design guide that Meath County Council have found. If you wanted to Google search that, Meath County Council Rural Housing Design Guide, and you'll see a return to a more traditional vernacular, if you like, a more simple design, simple traditional Irish design. Some of these features that we've inherited and designed and built over the years, particularly in residential construction: bay windows, projections, valleys, hips, porticos, windows of unequal proportion, faux stone to the front. A lot of those details are people's aesthetics, so the individual homeowner likes them, but they may not be traditional in terms of shape or vernacular style, etc. Not only are they in some ways not a traditional style, but they're also an expensive way to construct. They're expensive in terms of time, and they're expensive in terms of labor, and they're expensive in terms of quality, and they're expensive in terms of cost. So all the 3 things that you want to try and balance as an architect, as a project manager, that triple constraint model: time, quality, and cost, all 3 of those are impacted by your choices when you go to design a structure that has a projection. So if you can avoid it at all, try and avoid it. If you can ask the client, why do you want to construct this? What is this doing? Can we achieve this in some other way? You're going to have an increase in junctions and corners of the walls. You're going to have an increase in internal walls, roof surface area, valleys, flashings, columns, beams, drainage, etc. Think about the structure down here. Think about the four corners. You could have a gully on each of those four corners that's carrying your rainwater goods. In some cases, you might only need one in one corner to the front and one corner at the back. If you consider the amount of individual returns and corners, each one of those will have to have their own downpipe. You can see the downpipes in there. And each one of those downpipes will have branches, and each one of those downpipes will have to be serviced and maintained and cleaned, and will have to run into underground drainage, and that all adds additional cost. So we try and avoid that if we can. At some stage I'm going to give you a demonstration of a takeoff using Qubit software. We'll be doing that in fourth year, so it'll tie into what we're going to do in fourth year. But it will give you a better understanding of how we produce bills of quantities and the manner in which each component and element is measured and costed and valued. And when you do your little search for Tony Cunningham's paper on the National Standard of Building Elements, you'll find the NRM one. So you'll be able to see an example of that. It's a summary page of the standard building elements. Please have a look at it before next week's class. So, here's another example of maybe a traditional housing estate. If you were to measure and assess the floor areas and the wall areas of each of these structures, and bear in mind that the internal dividing wall, so the party wall, does have a cost, but it's not going to have the same cost as the external wall. You're not going to have the same level of insulation, external render, etc., etc. Probably lighter foundations also. So what I'd be curious is if you were to do a little assessment of that, what would you come up with for floor to wall areas for each of those structures? And if you're working off a simple rule of thumb like a cost per square meter, would the cost per square meter be different for A compared to C? Would the floor to wall ratio be different? Would the volume of external walls be different? A could be in a traditional housing estate, A could be a detached house, B could be a semi-detached house, and then C could be a terraced house. So maybe when you're looking at the external wall, floor to wall ratios, if you were to calculate those for each of those three, A, B, and C, and then compare them to D and E, you might determine that for the same floor area, you have different wall areas, particularly external wall areas. And in doing so, you'd arrive at a conclusion about costs and how it would impact on whether it was a detached house or a terraced house. So what I'd like you to do is I'd like you to consider this exercise here. You can pause the video here now at this point. This is the end of the video. This is going to be your assessment for next week. I would like you to pause this. I would like you to calculate each of those areas and walls in terms of this is an industrial building example that we have here, and I'd like you to consider the effect of constructing a one-story office next to a production area, or a two-story office within the same structure, or a lean-to one-story office, or a two-story office to the front of the structure. So you've a number of different plans and sections there in front of you. Be mindful to read the sections and take your time and try and calculate the exercise. Try and base it initially on area and external walls, so the same floor to wall ratio calculations, but also then start thinking about other implications. Are there any other implications of where you construct the office and how you construct the office? Maybe have a little look at that for next week. Okay guys, I'd also like you to do something for me this week which is different to what we've done before. I'd like, when you've done this assignment on industrial buildings, so you've paused the video and you've calculated the floor to wall ratios, I'd like you to write a short response, maybe about 200 words, and I'd like you to post it in the discussion forum. So I'd like you to go into Brightspace, go into discussions, start a thread and write a discussion based on what you've discovered here this morning. And when you finish up with your discussion, I'd like you to ask a question. I'd like you to consider, what is it that's missing from this, or is there something about your understanding of this that's not 100%. You have a query about something. Everybody has queries, always. I have queries looking at this. So if I have queries, you have queries. So just maybe write a query, and then once you've written your query, you've written your discussion piece, I'd like you to come back another day later and try and read other people's posts and other people's queries, and maybe try and answer one of them yourself. So don't answer your own, try and answer somebody else's. What I'd like to do is I'd like to get a discussion going here, where different individuals have different posts, and then they discuss it. So in the same way as you might have done that in your lecture space, you might have discussed over a cup of coffee what you were doing. I'd like you to do the same thing here. And I'm going to pop in every so often. I'm going to turn on my notifications when there's a new post. So within the next 7 days, if you can sit down and do this, my recommendation is you do it today, and you send in your 200-word response, and then reply to that person. Maybe reply, keep your replies maybe to about 100 words. So you can do your calculations, you can ask your question, and then go back and reply to somebody else's post. So you might need to revisit, because if you do your post and there's no other posts there, you might have to revisit. So see if you can do that. I'm going to pop in and I'm going to check the discussion forum over the course of next week, and I look forward to chatting to you then. Okay? Thanks guys, thanks for watching, take care, bye.